Hey everyone, starting with this lesson we're going to dive into arrays. Up until now, we've been working with individual data like variables and constants. Sure, we could create multiple variables and constants, but they weren't really connected. So why do we even need to connect data like that? The thing is, in programming, there are lots of situations where we need to work with a group of data at once. For example, imagine you're asked to write a program that asks the user for the ages of several people. They enter the value and then you do something with that data. With the knowledge we have now, we could create several variables and then write the same command over and over again where the user inputs the ages. But already there are a few problems. What if you need to ask for the ages of 20 people? In that case, you'd have to manually create 20 variables. That's slow and boring. Each variable would need a unique name. Then you'd have 20 identical commands for inputting ages. Now, let's say the task gets a bit more complicated and we need to make sure that if the user enters a negative value, they're asked to try again. Now, one command turns into several lines of code and you'll have 20 of these sets. And then someone says, let the user first enter how many people's ages need to be input. Now you're stuck because you don't know how many variables you need to create, and that's exactly where arrays come in handy in programming. So let's move on to arrays. An array is a named group of variables of the same type. That means when you create an array, you gotta specify its type, name, and size. In other words, you can think of an array as a named collection of numbers or a sequence. There are fixed size arrays. These are arrays where the size is set when you create them and it never changes. And there are variable size arrays. These are sometimes called dynamic arrays, but personally I don't really use that term. With these arrays, you can change their size all the time, but we'll talk about those in separate lessons. For example, when we cover pointers, we'll touch on this topic a little bit. And there will be a separate lesson on the std vector class, which many people consider a dynamic array. Arrays can be one-dimensional, multi-dimensional, or strings. The next 3 lessons, including this one, will be about all these kinds of arrays. In this lesson, we're focusing on one-dimensional arrays, which are the simplest type. They've just one size, which is the number of elements in that array. Now, let's move on to creating arrays. There are a few ways to create an array. In all cases, you gotta specify at least the array's type and name. So what's the type of an array? It's the type of each element in the array. For example, you can't create an array with 2 variables, one being an int and the other a double. All the variables have to have the same type and you specify that first. Later, we'll learn about the auto keyword and decal type, which will let the compiler figure out the data type for you, but that will be covered in separate lessons. After specifying the type, you gotta give it a name. Why is that important? For the same reason you need to name variables. Your program can have lots of arrays and other data, and to know which data to work with, it refers to the array's name. Just a reminder, in case I haven't said it before, variable names are all for programmers, not for the computer. After compilation, they turn into addresses that look like regular numbers, but it's easier for us humans to remember names rather than addresses. The same rules apply to naming arrays as they do for variables and constants. Names can't start with a number and can't have special symbols except for the underscore. Next, you open square bracket. Their presence always indicates it's an array, not a variable. Inside the brackets, you specify the array's size, meaning the number of elements. Here are a few examples of creating arrays. The first one is an array named points with 5 elements of type int. The second one is an array named sides with 4 elements of type double. The third one is an array named word with 6 elements of type char. But what do all these arrays have in common? They're uninitialized. That means the elements don't have any value or their value is garbage. I already mentioned this in the lesson about variables. The same rule applies here. You might notice that under these array names, there are 4 dots. That's a hint. If you hover over it, it'll tell you that the arrays are uninitialized, assuming they're local variables. Local variables are those that are inside a block, in this case the main function. There will be a separate lesson on local variables. You can use the hint and click the light bulb, and it'll offer to add an initializer. This way, all elements will have default values. For numbers, that's 0. For bool, it's false, and for char, it's the null character, which we'll talk about in 2 lessons. I'm gonna use that for now because we can move on to the next way to initialize arrays, specifically by using that initializer. You can write it with or without the assign sign, doesn't matter. I prefer using the sign. If the curly brackets are empty, it means the elements get their default values. In the 3 examples below, you'll see how I use the initializer. But thanks to it, you can set initial values for elements. Here's how. You provide the value for the first element, then the second, then the third, and so on, either until the last element or until the one you need. In this case, these curly brackets are called an initialization list. There is a special class in C++ called std initializer list. There will be a separate lesson on it, but not anytime soon. Now, if an array has 5 elements and you provided 5 values in the list, everything's fine. Each element gets its value. But what if there are fewer values than elements? For example, in the second array, we have 2 elements, but I only initialized 1. In this case, all the remaining elements will get default values. In this example, the second element will get a value of 0. If you provide more values than there are elements, you'll get a compile time error. And finally, let's talk about the last way to create an array. When you use the initialization list, the compiler can count how many values are in it, and if you didn't specify the array size, the compiler will figure it out for you. For example, if we have 3 values but no size specified, the compiler will set the size to 3. Alright, we've learned how to create arrays, but what's the point if we can't actually use the elements inside them? So now let's move on to array elements. Each variable inside an array is called an element of the array, and every element has its own number, or more accurately, its index. Indexing in C++ starts at 0. That means the first element has index 0, the second one has index 1, and so on. So the last element of an array will have the index array size -1. Why does indexing in C++ start from 0? It's because the index represents how many memory cells to skip from the address of the first element. When we get to pointers, I'll explain that in more detail. For now, just remember this rule and never forget it. There is a classic, kinda stereotypical joke about programmers that even in real life they start counting from 0. And that's just because so many programming languages work that way. Cool, but how do we access all elements in an array? Simple. You write the array's name, then in square brackets you put the index of the element you want. Here's an example. I create a regular array, initialize it, and then I want to print out all its elements. I do that like this. You'll notice we're repeating the same command, only changing one number. Can we throw this into a loop instead? Yep, we can, but more on that later. When you access an element, remember it's just a regular variable. That means you can use its value and also change it, like I'm doing here. Let's run the program and check the output. Now, this might sound weird, but technically you can use negative indexes and even indexes that aren't valid for the array. Like here, I'm trying to assign a value to index -1. This behavior is called undefined, and you really shouldn't write code like this. What actually happens is the address of the 0th element, what normal people call the first, gets shifted back by 1 position, and we have no idea what's sitting at that address. It might be your own data, in that case the program will just override it, or it might be data from some other part of the program, and that could lead to a crash. Now, you might be wondering, why even allow this? why doesn't the compiler catch it? Well, first, this limitation is left out for the sake of performance. For example, in C# language, every time you access an element, it checks the index, which makes things safer but also slower. In C++, there are ways to check the index, and we'll definitely get into that later, just not now. Same thing goes for when you use an index that equals the array size or is greater than that. Again, undefined behavior, so try to avoid stuff like that. And one more thing I want to cover, you're not limited to using just literals as indexes, which is what we've been doing so far. You can use variables, constants, or even expressions. What matters is the value. And lastly, you can't use floating point numbers or strings as indexes. If you use a bool, the number value is used, in this case 1. If you use a character, its ASCII value is used. Here it's 103. But don't do that. Later on, you'll run into code where you'll see stuff like strings or floats inside brackets, but those won't be arrays. Those will be more advanced containers. I'll talk about those in some far, far away lesson. Alright, I think it's time to explain how arrays are actually stored in memory. I drew this beautiful little picture. Okay, maybe not beautiful, calling it art would be a stretch, but at least it should get the point across. You might remember I drew something similar back in the lesson on variables. So let's refresh a bit. We've got RAM. That's where all the data lives when you create stuff in your code. Each byte in RAM is like a tiny square. Every square has its own address, but we don't really care about that right now. What matters is that all these bytes are lined up one after another in a big row. That's why I drew a chain of squares. Now remember, an int takes up 4 bytes in memory. A char only takes 1 byte. When I create 2 regular variables, here's how they get laid out in memory. 4 bytes get set aside for the int. That chunk is labeled with the variable name and we store the value there. If we don't initialize the variable, it just holds some random garbage value, same as we talked about earlier. But when we create arrays, things look a little different. I made 2 arrays here. They've got different names, different sizes, and different data types. The first array is initialized. It's got 3 elements, and since each element is an int, that's 3 times 4 bytes is 12 bytes total. So a 12-byte chunk of memory gets reserved, labeled with the array name. This chunk has a specific type. We can call it an array of ints. And inside it, we've got 3 variables. Notice, these individual elements don't have names, but we can still access them using indexes. See, the array name is also basically the address of the first element. So if we add 0 to that address, boom, we're still at the first element. Add 1, now we're at the second element, and so on. The second array is smaller, fewer elements, and each element only takes up 1 byte, because it's a char. And since this array isn't initialized, all the elements are just holding garbage for now. That's it, simple as that. Up until now, we've been creating regular variable arrays. That means the arrays were holding variables inside. But we can also create constant arrays. I'm guessing you already figured it out. Those are arrays where all the elements are constants. And do you remember what makes a constant special? It has to have the const keyword. It must be initialized when it's created, and you're not allowed to change its value later. So, to create a constant array, you just put const before the data type, and you have to use an initializer list when creating it. That way, you'll end up with several constants stored in an array. You can read their values just like you would with a regular array, but if you try to change any of them, boom, you'll get a compile time error. Alright, now it's time for the good stuff, loops. The thing is, working with arrays almost always goes hand in hand with loops. Most of the time, you'll need to perform some kind of action on all elements of the array, like printing all the values to the screen, calculating their sum, finding the largest number in the array, sorting the array, and so on. There are tons of things you could do. I've written 3 examples where loops are used. In all of them, I used a for loop, and here's why. You're doing something with every single element of the array. You already know how many elements there are, so you know how many iterations the loop needs. And what's the best type of loop for a known number of iterations? That's right, a for loop. Take a look at the first example. Notice the constant I used? It holds the number of elements in the array. You can't change it. By the way, when defining array sizes, you can use either literals like 5, 10, etc., or constants, but not regular variables, because arrays are created at compile time and variables only get their values at runtime. My recommendation? Use constants for array sizes whenever possible. It makes your code cleaner and easier to manage. Just look at the second example. The array size is 3, and that size is used in 2 places, in 2 different algorithms. Both use the same constant. Now imagine if you hard-coded in both places and later decided to change the array size to 5. To hardcode something means to write fixed values directly into your code instead of using variables or constants. So you'd have to track down every 3 in your code and change it to 5. And what if you miss one? That's where bugs come from. But if you use a constant, you just change its value in one place and you're done. Plus, this helps solve the problem of magic numbers. A magic number in code is a number whose meaning isn't clear. If another programmer sees a for loop that runs 3 times, they might wonder, why 3? What does that mean? But if you're using a named constant, it tells them right away, this number is the array size. Back to the first example. I made an array with 5 elements and filled it with values. Then I used a for loop to go through each element. How does it work? We declare a counter variable, usually named I, J, or K. Don't worry, in this case, those short names are totally normal and understandable. The counter starts at 0 because remember, array indexing starts at 0. Then we write the condition I is less than size 1. Take a look at the increment at the end. The counter increases by 1 every time. So each loop cycle, we access the next array element. Important, I use the less sign, not less or equal, because we don't want to go past the last element. That would lead to undefined behavior. Inside the loop, I printed the array elements one by one, separated by a space. The output should be what you'd expect. Now, the second example. We want to find the sum of all the array elements. Before looking at the code, try to think through the logic. First, we create a variable to hold the sum, starting at 0. Then we run a loop, and for each element, we add it to the sum. When the loop is done, we've got the total. At the end, we print both the array and the sum. Let's run it and see what we get. In the third example, the user enters values for the array, and then we find and display the maximum value in it. So first, I create a 5-element array. At the start, it's filled with garbage data. The user will input the real numbers. I run a loop asking the user to enter each value. Notice the prompt I give before the input. It tells the user what to type. Always do this in your programs. Never leave the user guessing. Once the array is filled, I print it for convenience. Now we need to find the maximum number. Here's how. We create a variable to store it and set it to the first element of the array. Then we loop through the rest of the elements, starting from the first, not the 0th, because we've already looked at the first one. In each loop iteration, we check, is the current element greater than the max value we have? If so, we update the max value. By the end of the loop, that variable holds the largest number, and we print it. Let's run it and see the results. I've mentioned this before, but now I can show it. The name of an array is actually the address of its first element. If you write this line of code and run the program, you'll see a memory address printed on the screen. And yes, it changes every time you run the program. If you're wondering what those weird symbols are, that's because the address is shown in hexadecimal, base 16. That's why you see letters along with numbers. Don't worry, I'll have a separate lesson about number systems later. For now, just remember, the array name is an address of the element at index 0. You can use that address, but you can't change it, like in this example. In the lesson about the for loop, I mentioned that there's also the range-based for. It's most useful with containers, but we can already use it because it also works with arrays. I show that a range-based for loop can work with a list of values. Now you know that this kind of list is called an initializer list. You should also know how this code works. On each iteration, the variable value is assigned a value from the list, and then we print it to the screen. But now, instead of such a list, we can simply write the name of an array. Here, I created a regular array and filled it. Then, in the range-based for loop, I created a variable element to emphasize that it will store the value of each element during the loop. And I print that value to the screen. What's the advantage of this loop compared to the regular for loop? It's shorter, but it has a drawback. You can't modify the values of the array elements because each iteration copies the element's value into the variable element, and in the loop, you're working with that variable. Yes, you can change its value inside the loop, but the array elements won't care. And yes, this problem can be solved. For example, by using a reference. You don't know yet what references are. There will be a separate lesson. I'll come back to this code and explain everything. For now, you just need to expand your knowledge of the range-based for loop. If your task is to read all the array values and print them in order, you can use this kind of loop. But in other cases, it won't help. For example, with the regular for loop, you can start not from the first element, but from the last one and go to the first, or not go all the way to the end. You set the counter variable yourself, and condition 2. But here, there's no such flexibility. Still, I'll repeat, we'll come back to this loop several more times, and there will even be a separate lesson about it, but not soon. Some of you might already know something about arrays and may have heard of or used constructions like std_array and std_vector. First, I want to explain what these are. Both of them are class templates from the STL library. And since in my course we haven't yet covered classes, templates, or the STL, I won't be going into them right now. But there will be a separate lessons about each of them in the distant future. For now, I can give a simple description. std_array is a more flexible and convenient fixed-size array compared to the arrays we've discussed in this lesson. And std_vector is considered by many to be a dynamic array, that is, its size can change over time. But I personally don't call it an array. It's one of the containers from the STL library. I've written some code here where you can notice a few things. First, you might need to include these two files in order to use these containers. Second, I showed how to create each of these arrays, although technically the last two are single objects. All of them can be initialized using an initializer list. And third, the range-based for loop works the same way with all of them. I'm going to forget about them for now, until the time comes for dedicated lessons about them. All this time we've been working with arrays that have only one size, which you could also call one dimension. But there are also two-dimensional arrays and so on. I'll be talking about those in the next lesson. To put it simply for now, they're just arrays of arrays. For example, this array consists of 3 elements. Each element is an array of 6 variables of type int. Finally, let's talk about strings. The thing is, when we work with arrays of type char, there are a few additional functions that make it easier to work with them. For example, you can initialize them like this, print them like this, and the address of the array won't be shown, and input information into them like this. I'll explain how all this works in 2 lessons. First, we'll talk about multidimensional arrays and then about string arrays. Also, you might be curious about these strings. Again, let me explain what they are. These are std string class objects, which are designed for much more convenient work with strings and text. But we'll cover this in a separate lesson once we've covered almost everything that makes up this construct. And that's the end of this lesson. Thanks so much for watching. If you enjoyed the video, you can support my work by giving it a like, leaving a comment, subscribing to the channel, becoming a channel member to get access to practice lessons, or donating via the link in the description. All of that helps the channel grow and keeps me motivated to make more lessons for you. Take care.